So, what if I told you that the key to understanding our ridiculously complex global economy isn't hidden in some dusty old textbook, but in a chemistry lab? I know, it sounds a little out there, but let's dive into this pretty radical new idea that smashes together two fields you probably never thought belonged in the same sentence: economics and chemistry.
We have all these metaphors for the economy. Most of the time, we talk about it like it's this giant machine, right? You pull a policy lever over here, you turn a gear over there, and you expect this very specific output. But does it ever really work that way? We all know it's way messier than that. So what if that whole machine metaphor is just wrong?
So, on the one hand, you've got the machine. It's predictable, it's mechanical, all the parts are supposed to do their job. But on the other hand, what about thinking of it like a chemical reaction? It's dynamic, it's complex, it's deeply interconnected, where just one tiny element can change the entire outcome. And that second idea, that's at the heart of what we're talking about today.
Okay, so if the economy acts more like a big, messy reaction, how in the world can chemistry, the science, actually help us figure it out? And this isn't just some cool, loose comparison. It turns out it's a framework for a whole new kind of analytical tool.
Here's the core concept. Just let this sink in for a second. Imagine every person, every company, every government is an individual atom. And every transaction, every policy change, every market boom or bust, those are the chemical reactions happening between all those atoms. It's a simple shift in thinking, but it completely changes how you see everything.
And believe it or not, this idea actually has a name. It was formally proposed by a researcher named Dr. Mario Arturo Ruiz Estrada, and it's called econochemistry. So let's break down what it actually is and how it claims to be able to model our economic world.
So here's the kicker. Econochemistry isn't just a metaphor anymore. It's defined as a field that directly applies the actual models and structures from chemistry to study the economy. Yeah, we're talking about taking the same rigorous frameworks scientists use to understand molecules and using them to understand markets. It's pretty wild.
And just like in your old high school chem class, it even has its own branches. You've got organic economics, which is all about looking at the primary raw economic data. And then there's inorganic economics, which works with the secondary and experimental data. It's really just a way to classify all the different economic compounds that we're studying.
Okay, that's the theory. It sounds cool, but how does this actually work? I mean, how do you visualize an entire economy as a chemical structure? Well, let's get practical and see how it gets built using something called the GB's model.
The whole thing starts with one fundamental building block: the general economic structure, or GES for short. And honestly, the best way to think of it is like a super high-resolution photograph. It's a complete, detailed snapshot of the entire economy at one single precise moment.
But here's where it gets really interesting. A GES isn't just one number, it's built in layers, kind of like a Russian doll. At the very core, you have the main structure. Think of that as the big number, like overall GDP. Then you go out a layer to the substructures. Maybe that's the performance of the manufacturing sector. You can keep zooming out through micro and even nanostructures, getting all the way down to individual industries or companies. Each layer just keeps adding more and more detail to that photo.
And this is where the model really comes to life. The size of each of those circles isn't fixed. It's determined by what's happening in the real world, by economic growth rates. So when an industry is booming, its circle gets bigger. If it's in a recession, the circle shrinks. You can literally see the economy expanding and contracting right there in the model.
Now, a single snapshot is useful, but the economy is more like a movie than a photograph, right? It's always evolving. So how does the model capture the flow of time?
This is where it gets really powerful. You take those individual snapshots, the GES units, from different points in time, and you link them all together in a sequence. This chain is called the economic base, or EB, and that becomes your movie. It represents the entire evolution of the economy over time.
And get this, the inspiration for this whole structure is one of the most famous chemical structures on the planet, the DNA double helix. And when you think about it, it makes perfect sense. It's a long, complex, information-rich chain that describes an entire system. That's exactly the goal here for the economic base.
So in this model, time isn't just a flat, straight line. It's a spiral. And every single point along this spiral is a complete economic snapshot, a GES. It's a way of showing how the past is always connected to the present in this continuous, dynamic, evolving structure.
Okay, so we've built this complex, DNA-inspired spiral of the economy. So what? What's the payoff? What new insights does looking at the world this way actually give us? The real power here is finally seeing the big picture.
This model is built to handle huge, messy data sets. I mean, we're talking about a country's entire balance of payments, and boil it all down into a single, holistic picture. It lets us stop staring at static tables and start watching the economy as a dynamic, living system, seeing those cycles of boom and bust in one intuitive glance.
And that's really the ultimate goal here, to move beyond endless spreadsheets and a million different charts, and instead create one single, unified, visual prototype for an entire economy, literally one model to see it all.
So, to put it simply, this entire framework is about a fundamental shift in our perspective. It's a move away from just analyzing history through static reports and moving towards observing the economy as a living, breathing thing while it evolves.
So it leaves us with a pretty provocative thought, doesn't it? If we reframe our entire view, if we start seeing economic players as atoms and events as reactions, are we maybe on the verge of a whole new formula for understanding our world? Could the future of economic breakthroughs really begin not in a bank but in a chemistry lab?